Hello friends, welcome back to the tetrahedron chemistry classes. So guys, I have given you a problem in your first assignment and unfortunately none of you solved it properly, right? However, the problem was very simple. The only thing you need to know was the basics involved in the chemical calculation. So however, without wasting too much of time, I am going to solve this particular problem for you so that you may have the reference to solve the further problem, right? Which I'll give you in the upcoming assignments as well. Okay. So the question was like that: 88 gram of the potassium dichromate is dissolved in 300 ml of the water in presence of the little sulfuric acid. Calculate the normality and the molarity of the solution, right? This is the problem. So however, there are two different approaches to solve this particular problem, right? First, you can solve the normality. You can calculate your normality, and after the calculation of the normality, you can go for the molarity, or you can do in the reverse manner as well. First, you can calculate molarity and then you can go for the normality. But according to me, it is important to solve this normality first, right? After that, you will convert that normality into molarity, right? This will give you the more insight to this particular problem to you, right? So that you may have better idea how to solve such kind of the problem. Okay. So first of all, you should know you have been given this potassium dichromate, which is your K2Cr2O7. And remember this K2Cr2O7 potassium dichromate in acidic medium, it's a very good oxidizing agent and it is used in the various reactions. Okay. So it will react with the sulfuric acid, and I hope you know how to write the balanced chemical reaction for this particular system, right? If you don't know, then there is no problem. I am writing this equation, right? So 2 of the potassium dichromate you will take along with the 8 moles of the sulfuric acid, and it will give you 2 of the potassium sulfate K2SO4, right? And your 2 moles of your chromium sulfate Cr2SO4 whole thrice, okay? And along with it, you will have your 8 moles of your water molecule, and of course 3 of your oxygen, right? The reaction is happening in the aqueous medium. This is aqueous. This is also aqueous, this is also aqueous, this is also aqueous. Water is already there in the form of the liquid, and oxygen is also there. Now, if you carefully see, right, what you can observe here, in that potassium dichromate, your transition metal is involved, and your transition metal have the variable valency. So, what you can do, you can calculate the change in the oxidation state, not valency actually, change in the oxidation state for this potassium dichromate when it is reacting with the sulfuric acid. It is very important, right? So later I will calculate this. First of all, say for example, I am going to calculate the normality. So I will write normality equals to, what is the formula involved for this? Number of gram equivalents of solute. Number of gram equivalents of solute, right? And in that case, your solute is potassium dichromate, okay? This should be divided by volume of the resulting solution, and you will take the solution in the liters, right? If you further break this particular formula, then what is gram equivalent basically? Gram equivalent is mass of substance, okay, which is given in the question itself. In that case, it is 88 gram, and divided by equivalent mass. So I am writing EM for this one, equivalent mass of substance, right? Your substance is potassium dichromate. Please remember, okay? And then your volume of the solution, it will be in the liter. Now the important thing is that how to calculate the equivalent mass of the potassium dichromate. So see here how we can calculate. I am writing here equivalent mass of K2Cr2O7 in acidic medium, right? That is equals to what? Molecular mass of K2Cr2O7 divided by N factor, okay? And in case of your oxidizing and the reducing agent, the N factor is actually change in the oxidation state of the metal involved in it. So here, instead of writing N factor, what I am doing, I am removing it. You can write n factor for your reference only. And here I am writing change in the oxidation state. Change in oxidation state. So what change is actually happening here in that case? So here you can see, if you know how to calculate the oxidation state, then it is quite fine. And if you don't know how to calculate, you can focus here. I am calculating for you. Okay. Say for example, you know you are calculating for the 1 mole of the potassium. Okay. Say you are having this K2Cr2O7, right? Potassium is what? 1 positive. It is present 2 times, right? So 1 into 2 plus you are calculating for the chromium. So X is your chromium and 2 times chromium is present. So you can write 2X, and you know plus -2 charge is present on the oxygen and it is present 7 times, that is equals to 0. And if you solve this particular factor, then you will find your oxidation state is 6. So here oxidation state of chromium is 6. But in that case of the chromium sulfate, right, if you are calculating for this Cr2SO4 whole thrice, right? So X is for chromium, this is present 2 times. So X times 2, and sulfate is your -2, right? So I am writing -2 times 3 equals to 0. And if you solve this, then you will get X equals to 3, right? So in that case, this is +3. Okay. Please remember, this calculation is for this one, right? This has nothing to do with this one, right? And then you can see here, I am going to calculate further, right? I am going to solve this particular problem further, right? So what is the change in the oxidation state? From here to here, change in the oxidation state is by 3 units. Okay, 3 units. So when the change is in 3 units, so what you can do, you can write the molecular mass of your potassium dichromate, and the accurate molecular mass of potassium dichromate is 194.185. This is the molecular mass of potassium dichromate, and change in the oxidation state is 3, as you have seen here. Okay, and when you solve this particular factor, it will come 98.061, right? So this is what your equivalent mass of potassium dichromate. Now I am going to solve this particular problem. So I hope this is quite clear to you. Now I want little space. So what I am doing, I am removing this part. Okay, I am removing this part 98.061. Okay. And I am also removing this part which I have already explained you, right? Because I need some space. Right. So now I am going to solve the problem. So what is the mass given? Mass given is 88 gram. You can see here 88 gram is given in the question itself. Okay. And this 88 should be divided by equivalent mass of the substance potassium dichromate, which you have calculated as 98.061. Now the volume of solution in liters, but you have been given this volume as 300 ml. So you need to convert this 300 ml into the liters. You know, when you divide 300 ml by 1000, then you will get the volume in the liters, right? So I am writing here 300 and I am converting it into the liters. So at thousands, I am dividing it with the 1000, right? So what you will have, see, 88 times 1000 divided by 98.061 multiplied by 30, right? It was 300, right? 300, 20 and 20 gets cancelled, right? And this will give you 880 divided by 98.06 into 3, and that value is nothing but it is your 294.185, which is the molecular weight, right? In that case, it is happening like that, right? Because you are multiplying this equivalent weight by with the factor which is equal to the your n factor, right? By the number which is equal to the n factor. So it is coming just like that, right? If you solve this, then you will find, I have already calculated this. So this will give you 2.99n. So this is the normality of this particular solution. Please remember, right? And if you go for the molarity, then you should know what is the relation between. So relation is like that. Normality equals to molarity into n factor. Okay. And you need to calculate molarity. So you can write m equals to normality over n factor. Your normality you have calculated 2.99 and your n factor is 3 in that case, right? N factor is 3 for potassium dichromate when it is reacting with the sulfuric acid, okay? And when you solve this particular problem, this will give you 0.997 of m. So this is your molarity, okay? And this is your normality, right? You should know these things. This is very, very important, right? So however, I think you understood this problem quite well now. Now you will, if you solve such kind of the problems more regularly from your textbook, right, then you will have the better idea to solve such kind of the problem. Okay. So I hope you like the lecture. Okay. If you like the lecture, please press the like button and do share my channel Tetrahedron Chemistry classes with your friends as well. Okay. I'll meet you in my next lecture. Thank you. Thank you very much.